Good morning, students. Students, this lesson is of class ninth for the subject of physics. Topic for today is some consequences of liquid pressure, and it is covered in chapter 4, that is pressure in fluids and atmospheric pressure. Children, we have already learned a formula last time that pressure is pressure due to a liquid column is basically equal to H rho G, where H stands for depth from the free surface. It is not height, rather it is depth from the free surface. Rho is density of liquid and G is acceleration due to gravity. Now children, originally if you are having suppose a glass of water filled with water, suppose you are having a container filled with water, and if you take a point, let the point be, let us take a point here A, and if I want to find the total pressure at point A, then this pressure will be because of the pressure from the liquid height, the depth of this point A from free surface. This is P, pressure due to liquid column. Moreover, atmosphere is also exerting some pressure, and that is known as atmospheric pressure, and we represented it with P naught. We see it, we say it as P naught. P naught stands for atmospheric pressure, and I'll write down this as P due to depth of water column, liquid column. So I'm writing it as PD. So the total pressure at point A, the total pressure at point A, what it will be? I'll write down it as pressure at point A, PA, is actually equal to PD, that means P, pressure due to depth, plus pressure due to atmospheric pressure, P naught. And children, atmospheric pressure, one conversion which I told you last time also to learn was ATM, atmospheric pressure. 1 ATM is equal to 1.013 into 10 raised to power 5 pascals. Or you can simply say 1.0. Sometimes it is taken as 1 only. 1 into 10 raised to power 5 pascals in approximation. So this is your liquid. This is your pressure being exerted at point at a particular depth from the liquid column. Now children, if we go down, we have started this also. The more we go down, the more pressure is exerted by the liquid. Now children, due to it, there are certain consequences which we are going to study today. First is construction of a dam. In figure 2 of your PDF and even in your book, we can see a diagram of a dam. A dam is thinner from the top, while as we move down, the dam is made a little broader. Why so? Now children, this happens because as we move down, the pressure due to depth increases, and to withstand that high pressure, we need a strengthened material which is provided by this broad part of the dam. If you see, there are 3 points PA, pressure at point A, pressure at point B, and pressure at point C. Pressure at point C is more than A. Therefore, to withstand the high pressure of this liquid, what we have done, we have made the dam broader from its base. Similar happens with the foundation of the walls, pillars also. The pillars are always made broader at the base to withstand the pressure of the building. Now children, see figure number 3. Here you can see an example of blood transfusion. Now, when this blood transfusion is taking place, the bottle in which you are having blood, it is kept at a higher height as compared to the person or as compared to the place where you want to transfuse the blood. Now the bottle is hung at higher position to increase the pressure of liquid, so it has high pressure to flow into veins of patient. Now if I take this point P, at point P, the pressure will be more. Why? Because this P point is lower as compared to the bottle of the blood. So more, if you go a little more down, the pressure will increase more, and thus it will be easy to inject a blood of sufficient pressure in the veins of the patient. Similarly, size of gas bubble inside the water. Children, when the gas bubble is formed at the bottom of the lake, it is very small in size. But as it rises, as it comes up, see in figure 4, the size of the bubble increases. Now, why so? So when the bubble rises in water, the pressure acting on the air bubble decreases. Now, when the bubble starts rising upward, depth decreases. Depth decreases means pressure also decreases. And if pressure decreases, we know that pressure and area are inversely proportional. Pressure and area are inversely proportional to each other. Thus, since pressure decreases, area increases, and therefore the gas bubble grows in size. This can also be understood by using Boyle's law, which you have studied in chemistry, according to which pressure is inversely proportional to volume. This is your Boyle's law. Pressure is inversely proportional to volume. That means as depth decreases, pressure decreases, and as pressure decreases, volume increases. So thus the size of the bubble, the size of the gas bubble increases as it rises from bottom to the surface. This you can see in cold drink bottles also, where a small bubble is formed at the base and a bigger size bubble can be seen at the surface. For this, children, you can shake a transparent water bottle partially filled with water. You will see the formation of bubbles as shown in figure 4, and you will observe that air drops will grow in size as they move upward. Now there is very interesting fact which you should know, children. Deep sea creatures, that means the creatures which live near the seabed, they live hundreds or even thousands of meters deep in the ocean. And of course, there is very high pressure. But these creatures have adapted to the high pressure and even low oxygen level. These creatures have also eliminated all excess cavities that would collapse under high pressure. In our body, you are having cavities. What happens? Because of high pressure, that cavities is having low pressure, and due to which your body can collapse. So in these sea creatures, they don't have those cavities. They have finished their cavities also. So now you can pause this session and learn the formula written on page number 1, which we did right now only. P is equal to P naught plus H rho G. And then, children, you can start doing some numericals which are based on this topic. Question number 1. See, calculate the pressure due to a water column of height 150 meter, and it is given that take G 9.8 meter per second square and density of water. Children, remember this, density of pure water, we'll take it as 1000 kg per meter cube. You have to remember this value. Density of water is 1000 kg per meter cube. Now, question is calculate the pressure due to water column of height 150 meter. So this water column is having a height of 150 meter. That means from this particular level to the lower level, the height is 150 meter. So you have to find the pressure. Use formula P is equal to H rho G. Put the values. Now count the number of zeros. The number of zeros gives you the power of exponent. See, it is 150 into 1000 into 9.8. Now we write down 15 and 9.8 together. And there are 4 zeros. See, I've marked with the dot. 1 dot, 2, 3, 4. So that means we can write down it as 10 raised to power 4. So your answer will come in pascals. That is 147 into 10 raised to power 4 pascals. Now similarly, let us do second question. Children, please pay attention to the conversions also. See, the area of base of a cylindrical vessel is 100 centimeter square. The base area of the base is given. Water is poured into it up to a height of 6 centimeter. So suppose you are having a container. We can say that you are having a container and the area of the container, the base of the container is 100 centimeter square. This is 100 centimeter square. And you have poured water in it up to depth of 6 centimeter. So find the pressure and the area and the thrust, sorry. We know pressure is force upon area also. And we know that pressure due to depth. What is the formula of pressure due to depth? H rho G. So P is equal to H rho G. Centimeter, children, now centimeter needs to be converted into meter because the SI unit of height or distance is not, it is not centimeter. Yes, it is rather meter. So 6 centimeter can be written as 6 upon 100 meter, or you can say 6 multiplied by 10 raised to power minus 2 meter. So when you have written this value, your answer will come as 6 into 10 raised to power minus 2 multiplied by density of water multiplied by acceleration due to gravity, which is given to be 10 in the question. So here, since now all the quantities are in SI unit, therefore our answer will come in SI unit, and the SI unit of pressure is, what is it? Yes, it is pascals. So the pressure in this case will come, pascals will be the SI unit. So the answer is 600 pascals. Now students, similarly, we have to find thrust now. Since pressure was thrust upon area and area is 100 centimeter square. So children, let's find the centimeter square into meter square. So listen, area was 100 centimeter square. Now what do we mean by centimeter square? Centimeter multiply by centimeter. And in 1 centimeter, we are having 1 by 100 of a meter. See, centimeter is small quantity. In 1 centimeter, we are having 1 upon 100th of a meter. So let us do the conversion. Convert centimeter into meter. So both the centimeters are converted into meters. So this zeros will cancel out. I am left with 1 by 100 meters square. Children, this 1 by 100 can be written as 1 upon, or you can simply write down, see, there are how many zeros? 2 zeros. But are the zeros in numerator? See, are these zeros in numerator? They are in denominator. So you write down 10 raised to power 2, but since they are in denominator, so here I'll take it as minus 2. So 10 raised to power minus 2 meter square is your answer here. So area, I will not take it as 100. I'll take it as 10 raised to power minus 2 meter square. Why I have converted into meter square? Yes, because the rest of the terms are in SI unit. So children, now put the value here and your answer will come out to be 6 newtons. You can try the conversion, do the question, put the value of pressure 600, multiply by 10 raised to power minus 2, or you can write down multiply by 1 by 100, and then your answer will come in, it will come as 6 newtons. Third question is, a hammer exerts, children, this is same as question number 1 of your exercise, and I have already solved this question in the previous PDF also. So children, kindly do this question yourself. Here we are having conversion of millimeter into meter. That also I want to discuss now. Now children, listen, 1 millimeter is 1 by 1000 of a meter square. Sorry, 1 by 1000 of a meter. If I used to write down 1 by 100, it is 1 centimeter. Since it is millimeter, its value is 1 by 1000 of a meter. So, how many zeros? 3 zeros. And they are in denominator. So, what shall I do? I shall put a sign of minus here. So, 10 raised to power minus 3 meter. So, I can say 1 millimeter is 10 raised to power minus 3 meter, and 1 millimeter square means, it means 1 millimeter multiply by 1 millimeter, or you can say millimeter multiply by millimeter. So it is 1 into 10 raised to power minus 3 meter multiply by 10 raised to power minus 3 meter. I have converted millimeter into meters. So it comes out to be 10 raised to power minus 6 meter square. So 1 millimeter square is equal to 10 raised to power minus 6 meter square. So you learn this conversion also. And then in the question, we were having 5 millimeter square. So it will be 5 into 10 raised to power minus 6. Now children, see. If 1 millimeter square is 10 raised to power minus 6 meter square, it means that 5 millimeter square will be, don't write down 50, it is 5 multiply by 10 raised to power minus 6 meter square. 1 millimeter square was only 10 raised to power minus 6. And 5 will be 5 times of this. So on both right side and left side, you have multiplied with 5. Similarly, if I am having, suppose I say find 21 millimeter square, how to write down? I'll write down 21, simple, multiply by 10 raised to power minus 6 meter square. So this is the way we do conversions. And I hope this is clear. Now children, further solving the numerical part, then you can find the area in meter square, and once it is done, calculate the answer using formula pressure is equal to thrust upon area, and your answer will come in pascals. Now, similarly, question number 4, the pressure of water on the ground floor. You might have experienced, students, that on ground floor, the water pressure is more, and at the top floor or at the first floor, the pressure of water is less. So if I want to find the distance between ground and first floor, I want to first find the difference between the water pressure, which is given to be 65,000 pascals on ground floor, and on first floor it is 40,000 pascals. Question is, find the height of the first floor. Height means you have to find the height from the floor of the ground floor. So children, the formula used is change in pressure is equal to pressure due to depth. That means difference, take the difference on left side and write down h rho g on the right side. Solve for the value of h and then you can get the answer. Now students, I have given the conversions which we will be using in chapter 4 as well as in chapter 5 in a tabular form. So 1 meter is 100 centimeter and 1 meter is also written as 1000 millimeter. So if you invert it, this was you were doing conversion from meter, bigger to smaller unit, meter to centimeter. Meter is big unit, centimeter is smaller one. While if I convert from smaller to bigger, that is from centimeter to meter. See, the answer is going in. If 1 meter is 100 centimeter, that means 1 centimeter is 1 by 100th of a meter. Look at the powers. If you're going from big to small, powers are positive. When you're going from smaller unit to bigger unit, then the powers are coming negative. Why? Because your answers are going in denominators. Your zeros are going in denominator. That's why it is happening. So you all are requested that first of all, you learn these conversions. They all are required and they are important to learn. And then afterwards, students, I have solved certain examples from the books also. And kindly go through these solved examples also. And try to solve this on your own in your physics notebook. And all the examples are shown diagrammatically so that it is easy for you to understand the formula. In few examples, in the question only, they are saying that use atmospheric pressure also. So when you are using atmospheric pressure, you will use the formula total pressure is atmospheric pressure plus pressure due to depth. But if you are not provided with atmospheric pressure, then you will simply use the formula P is equal to H rho G. So children, with this, I come to an end to this session. Kindly go through all the examples, that is from 1 to 12, and also learn the conversions also, children, since it will be used in our next exercise also. So I hope you understand. Thank you, students, and have a nice day.